Hello guys, welcome back to Mindandera Academy. Today we are going to focus on stoichiometry. This will be our third video on stoichiometry. So we are going to balance chemical equations and also to calculate the reacting amounts in a chemical equation. Okay, so we are going to make use of this example in order to master some concepts on stoichiometry. Okay, so we have got the question, and the question is saying write a balanced chemical equation for the reaction between oxygen and propane. Okay, so we are seeing this reaction involves oxygen and propane as the reactants or the reagents. So the type of reaction automatically is a combustion reaction. So this propane is a fuel which burns in the presence of oxygen. So to answer this question, we are saying when oxygen and propane react, they produce carbon dioxide and water. That's the general weight equation for for the combustion reaction. So we can write oxygen is O2. So we are saying this one O2 plus propane is 6,3H. Then plus, okay, there is an R end here. We put an R end. So we produce carbon dioxide plus water. So this is the chemical equation for the reaction between propane and oxygen. So what we need is to write the state symbol of each substance in the equation. So oxygen is a gas. So we put a small letter G. Then for the propane, it's also a gas. Then carbon dioxide, also a gas. Then water, usually we write N for the liquid. Then that's the equation. So we want to make sure that the reaction or the equation is balanced. Okay, so we have got three carbon atoms. So for the combustion reaction, we first balance the number of carbon atoms. It will be very easy for you to make sure that the reaction is balanced. So we should have three atoms on the right hand side. So we can write three molecules of carbon dioxide. Then for the hydrogen atoms, we have got 8 on the left hand side. So we want to make sure that on the right hand side there are also 8 atoms. But for each water molecule, there is 2 atoms of hydrogen. So to make them 8, we multiply it by 4. So there must be 4 molecules of water which are produced. Okay, so the remaining ones are the atoms of oxygen. On the right hand side, we have got 4 plus 3 times 2 because in each carbon dioxide molecule there are 2 atoms of oxygen. So in 3 molecules of carbon dioxide, there will be 3 times 2, which is 6. So 6 plus 4 is 10. Okay, so on the left hand side, we must have 10 atoms of oxygen. But here, each of the molecule is carrying 2 atoms, so we multiply by 5. So that we have balanced the number of atoms on both sides. So that's it on part A. This person. So this question is answered. Then we can move to part B. So this is part A. Okay. So the question is saying if 0.25 mole of propane were burned, calculate the number of moles of carbon dioxide produced. So we want to know the quantity of carbon dioxide which is produced. But our standard is propane. So we have the quantity of propane burned, which is 0.25 moles. Okay. So we can use the stoichiometry ratios to find the quantity of carbon dioxide produced. So from the equation, we can say the proportion of propane to carbon dioxide, we can say propane is to carbon dioxide. So we are saying there is one molecule, so the ratio will be 1 is to 3. So if we burn one molecule of methane, of propane, we produce 3 molecules of carbon dioxide. So that's the stoichiometry ratio. Okay. So for us to calculate the quantity of carbon dioxide produced with this added quantity of propane, we can say 0.25 corresponds to what? So do we need more or less here? Because when we burn one molecule, there will be 3. So what about 0.25? We decrease the amount. So we need less. Yeah. So if we need less, we say 0.25 over 1 times 3. Okay. So we can make use of calculator to make it very simple. So we are saying 0.25 multiplied by 3. It's 0.75. Okay. So it's 0.75 more carbon dioxide. Carbon dioxide. So that's the number of moles of carbon dioxide which are produced when 0.25 mole of propane were burnt. So that's it. Don't forget to like the video, share, and subscribe to our YouTube channel. Thank you.